Hello everyone, how are you? I hope you people are great. So let's dive deep into the topic of percentages. We have already done 2 lectures on percentages and this one is going to be the last one. So let's wrap it up. The first topic which we need to do is percentage change graphic and its applications. Okay, so let's begin and let's understand what this exactly is. Now, in mathematics, there are many situations where one is required to work with percentage changes. Correct? Absolutely. Now, in such situations, the following thought structure, something which I call percentage graphic, is basically very useful. Okay, so let's suppose you have to increase the number 20 by 20%. So, how can we visualize this? Okay. Now, a very simple technique by the help of which I can visualize this is this. Okay. Now, what this is saying is that there is a number 20 which I need to increase by 20%. So, there has to be an increase of 20%. Alright. So, the increase of 20% is going to give me 24. That is, there is addition of plus 4 units in this. So I can write plus 4 here. So this is the way I can actually graphically show how I can write this. Now tell me one thing. If you guys are given two options, one in this format and one in this format, which one is more appealing? Obviously, I would say the latter one is more appealing because by seeing you can automatically tell that the initial number is increased by 20% to the final number, and in doing so there is an upliftment of 4 units in it. Correct? So this is exactly what we are utilizing in showing this in this format. Okay. So I hope you people understood this one. So let's move to the applications of it. So the PCG is what? Percentage change graphic. I've already told in the previous line that it's percentage change graphic. So do not get confused that, oh my god, now what this PCG is. So percentage change graphic has 6 major applications. So let's see what are these. These are the 6 major applications. That is your successive changes, your product change application, your product consistency application, and then A to B to A application, then denominator change to ratio change application, and use of PCG to calculate your ratio changes. So let's understand a few of these and let's do some questions related to them as well. Okay. So what is the first application? The first application is PCG applied to your successive changes. So this application is going to be utilized when I need to do some successive changes. Okay. Now, this is one of the most common situation in most questions. Okay. Suppose you have to solve a question in which there is a number 30 and it has 2 successive percentage increases. Initially, it is increased by 20% and then by 10%. So I can very well portray this with the help of this. Now this shows what? This shows that 30 was increased by 20% initially. Instead of writing increase, you can also show an upward arrow, and instead of writing decrease, you can also show a downward arrow. Okay. So 30% was increased by 30 was increased by 20% to make it 36, and 36 was increased 10% to make it what? 39.6. So the increment when 30 was increased 20% to make 36 was 6. That is positive 6. Then the increment when 36 was uplifted by 10% to make it 39.6 was what? It is positive of 3.6. So this is how you represent it. Okay. So let's understand this with the help of an example. Now the question says A's salary increases by 20% and then it decreases by 20%. Okay. Now what is the next net percentage change which is going to be in your A's value? Okay. So suppose the value of A is 100 because I'm talking in terms of percentages. So let me take a whole as 100. So from 100, suppose there was 20% increase in the salary which is given there. Okay. So a 20% increase in the salary is going to be what? A 20% increment in your salary is going to be 120. Correct. So how many units increased? Positive of 20. Correct. Now there was 20% decrease in it. Now because of this 20% decrease, 120 is going to be converted to what? 96. So how many units are lost? 24. And because these units are lost, I could say that it is negative of 24. Okay. So hence a salary has gone down by how much percentage? It has gone down by 4%. So 4% decrease is there in the salary of A. Alright, so this is how you can solve it, and this was based on your application 1. Alright, so let's study the application 2, where application 2 is PCG applied to the product change. Okay, and there is this one formula which we need to apply for this. But initially let's understand what the concept is, and then I'll tell you how to apply the formula. Now suppose you have a product of two variables, and let me say that the two variables are, let's suppose that they are 10 into 10. Now their product is going to be 100, right? But let's say that the first variable changes to 11 and the second variable changes to 12. So what I'm saying is that instead of 10 into 10, it becomes what? 11 into 12. That is, one variable changes to 11 and the other variable changes to what? 12. So what will be the percentage change in the product? This is exactly what I need to find out. Okay. So now, can you people see one thing? That the change in the first number is 10%, whereas the change in second number is what? 20%. So change in one number is 10%, whereas change in another number is 20%. So can I use these changes in the numbers itself to find the change in the end product? Exactly, I can do that. So here what I am going to do is I am going to assume that 10% is nothing but it is A, and 20% is nothing but it is B, and then I am going to apply this formula, that is A plus B plus AB by 100, that is 10 plus 20 plus 10 times 20 by 100. So it's going to be nothing but 20 plus 10 plus 2, that is 32. So this is what we were talking about, and this is exactly what we are doing. Okay. Now 10 and 20 are what? They are the respective percentage changes in the two parts of the product, right? Now this is actually being taught as a shortcut at most of the institute across the country. Alright. Okay, so let's move on to application number 3, that is nothing but product constancy application. Okay, so here what is happening is, suppose you have a situation wherein the price of commodity has gone up by 25%. In case you are required to keep the total expenditure of the commodity as constant, you would obviously need to cut down the consumption. But you need to find out by what percentage. Let's see what I'm saying. Suppose 100 is what the price is and it has gone up by 25%. Okay, that means positive of 25 will be added to it. So the answer is going to be nothing but 125. And I need to keep it constant. So obviously negative of 25 is what I need to do in order to bring back 100. Okay, that is hence the percentage which has dropped in consumption to offset the price increase is what? 20%. But I leave it to the students to actually discover the percentage drop which is required in the second part of the product if one part increases by 50%. So what I need to do is I need you to understand that if one part actually increases by 50%, then what is going to be the product drop. Okay, so you people have to calculate it. I'm not going to calculate it because I have explained this concept n number of times today. So just try it. Okay, give it a try to your own. Okay, so this method is basically what? It's another thing for what? Your inverse proportionality. I'll write it in another color. So inverse, my god, my handwriting. So inverse, inverse proportionality. So inverse proportionality, okay. So it's also termed as your inverse proportionality. Next is what? Next is application of A to B to C. Now very often we are faced with a situation where we compare two numbers, say A and B, and in such cases if we are given a relationship from A to B, then the reverse relationship can be determined using PCG in much the same way as in the previous method which we have just studied. Okay, so let's understand this with the help of an example instead of understanding everything here itself. Okay, so here is the question which I was referring to. So B's salary is 25% more than A's salary. That means B is obviously earning more than that of A. So by what percent is A's salary less than B's salary? Okay, so let's suppose 100 is where A is and 25% increase in 100 is going to give me what? Salary of B, that is 125B. Now obviously if I want to go from 125 to 100, which is what salary of A, I have to subtract it what? By 25. So the drop is what? The drop is 20%. Okay, hence A's salary is 20% less than that of B's salary, and B's salary is what? 25% more than A's salary. Okay, so can you people tell me why this is happening? A's salary, actually B's salary is 25% more than A's salary, and A's salary is 20% less than your B's salary. Why is this happening? This is happening because the base is changing. What is salary of A with respect, what is salary of B with respect to A? That means I have to tell the answer with respect to A, that is 100. Here what I am asking is that what is the salary of A with respect to B? With respect to B means 125. So the base of the ratio by which I need to calculate the percentage is changing. Therefore, the amount of percent is also changing. Alright. I hope you people have understood this. So let's move forward to the next topic, that is calculation of multiplication of numbers like 0.xy, 1.ab. Now in my opinion, the calculation of multiplications of any number by a number of the form like these should be viewed as a subtraction or addition situation and not as a multiplication situation. Okay, let me explain you how. Let's calculate 1.23 times 473. Okay, now understand this very carefully. If we try to calculate this by multiplying, we will end up going through a very time-taking process which will yield the final value at the end but nothing before that. Correct? That is, you will have no clue about the answers range till you actually reach the end of the calculation. That is true, right? Now instead what one should do is one should view this type of multiplication as an addition of 23% to the original number, right? Now this means what? This means I can write it as 473 times 1.23 is nothing, but it is actually 473 plus 23% of 473. Correct? Correct or not? I hope it's understood. So how can I write this? I can write this in the format of 473 plus 23% of this can be taken as 94.6 plus 3% of 473, and similarly I can write it as 567.6 plus 14.19, which is nothing but 581.79. So what I'm basically doing here is I'm trying to convert this into the percentages format. Okay, now the percentage rule can be used to calculate addition to get the answer as well. Okay, hence you are advised to become thorough with the percentages rules and the percentage calculations and addition of 2 to 3 digits number. So it was very simple. I just converted this into this format and then we did the calculation part. I hope you people have understood everything and you had a great session. I'll meet you next time with yet another topic. Thank you very much. Have a good day.